I have the AMD Instinct MI60 GPU. Now, before we continue, I'd like to implore everybody who's watching to subscribe. A lot of you, the majority of the viewers actually are not subscribed. It's free to subscribe, and it helps out the channel because the more people subscribe, the more the algorithms send out these videos, and it gets more people to obviously share information, which I can then share with you guys. Now, of course, I do a lot of research myself, and the information I find, I do share. But what I've noticed, because I do live streams, is that in the live streams, people can simply join the live stream and the live chat, and then they'll post their their advice, and I can share with you guys as well. For example, I always take that advice and I always create specific videos such as this one based on that advice. Okay, with that said, let's get back to the tutorial. You should subscribe, like, and follow as well. All right, so why did I need to install ROCm 6.4? Well, as you guys know, I actually uninstalled ComfyUI and I moved to stable-diffusion.cpp. Now that was working very well for me. I was very happy. I even compiled it using Vulkan, and that worked extremely well. Then a recent update kind of broke things. I wasn't able to get any videos at all, and the pictures are actually not very good. So I tried a few things, and that's when I found out that my GPU was no longer supported, because the last time AMD supported officially was at 6.3. Now, that is not the end of the story, because I found out some interesting things. Is that from 6.4 and 7.0, the AMD didn't actually, they officially say they're not supporting anymore, but it had been deprecated since I think 5.7 series of ROCm. However, all they did in 6.4 is they just removed the tensor file. So all you have to do is just add the tensor files back and everything will work. Now the problem is that some applications, including ComfyUI, what they will do is they will take the official support, which would be, for example, they will say, oh, your GPU is no longer supported, you need to drop down to 6.3. So I don't like that, because it is supported. It's not officially supported, but all you have to do is just get an old version of ROCm and grab the tensor files and put them in there, and it will perfectly work. Now, if you're able to install an older version, sure, go ahead. But I said for me, I'm using Fedora 43. It comes with 6.4. And one of the nuisances about Fedora 43 is when I uninstalled ROCm, I thought that would fix it because I was going to compile it myself, is that it also uninstalled stuff like Blender and llama.cpp, which I do need. So when I tried to install ROCm again, so I'm thinking, what is going on? So I found out all the information. It's actually pretty easy. All you have to do is, I said, just put those tensor files back, and then sometimes there's some flags you need to do, then you'll be fine. Everything will work again. Now, obviously, since they're no longer supporting it, meaning that there's not going to be any, if there's any bugs, they won't care about it, or if there's any, new features. Obviously, you're never going to get any new features. But that's fine for the use case. So I'll tell you some information I found. So what I should actually do here is, I was going to scroll down a little bit. So if you don't know about my GPU, it's AMD Instinct MI60 32 gigs HBM2, and I said the last supported version was 6.3 officially by AMD. Now, as I said before, I did find some information, so hopefully I have the links here, or I might have them in a nice stream. Let me just. Yeah, so I want to share a few things here first. One was, I shared this last time as well in the tutorial. I'll share it again in the night stream. So I'm going to open up a link here. This was one of my viewers. He actually posted this. It's actually on GitHub. It's in Italian, but it's pretty easy to follow. Obviously, you can translate it yourself. So as you can see, I'm guessing it's a he. The name is WASD. He actually emailed me through my contact form. and let me know that you actually created this article. Surprisingly, about the same time, you see, I actually created this about the same time that I actually created the video of how to run ROCm. I think it was in DistroBox. So basically, if you go here, you can see he's basically saying this, she is saying the same thing, and you can see you can either use ROCm 6.7.02 or 6.44. There's somebody who also was able to get it to run. No, sorry, that's not correct. Yeah, so this person was able to get it running in 7.02, and I said I'm in Fedora 43 where they have 6.44. So as you can see here, the instructions, obviously that's a Debian based one, but the same things do apply. And you see the export here. So this is the trick. Make sure you have the export here, so the applications which are looking for that specific your device will be able to to get it right. Now, obviously, if you have a supported device, it's not a big problem. But if you have an unsupported device like I do, this is what you do, and you'll be able to get up and running. Now, it is true if you have an AMD device, whether you're on Windows or Linux, it's a little bit of a pain to get AI stuff working, but it's still worth it for the price. For example, I just found out recently like the AMD MI60, the 32 gig one, the price went up. I thought I paid a little bit more than I'd like to back in the summer, but the price actually has actually gone up. So it is still worth it for you. So you can see here where you're learning, I say DistroBox. You can just follow instructions. I said, you can do a translated. You can translate. So this article here, I did post it. I said I'll post it again, just in case some people did not get it the first time. I'll talk about it as well in tonight's live stream. So I'm going to post it in YouTube. I'm going to post it in BitChute as well. So it is still worth it. Alright, so I'll post it in BitChute, and I'm going to post it in Rumble now. Cannot post a cannot insert a command after other text must be first. Okay, I think I need to I think for Rumble I need to refresh first, and I should be able to paste it here now. It says I cannot insert a command after another text must be command first. Okay, maybe I'll put hello. Let me put hello first. Oh, okay, I will just say the link. The link? No? Okay. I don't know what's wrong here. I'll say hello. Okay, now can I paste it? It says cannot insert a command after other text commands must be first. I don't know. Okay, it does work. I don't know what. Okay, that was a weird. That was super weird. All right, let's go to, what is this one? That's a past one. Why does it do it? What the? Oh, 11 minutes ago. Okay. It looks like the 11 minutes looked like it said 11 months ago. So I'm gonna paste that as well. Okay, that's been pasted. Okay. I don't know what is wrong with BitChute. Is weird. The chat never shows up. That is super weird. Okay, so back to my point. So yeah, as you can see here, the person had how to install ROCm. Obviously, I just follow instructions. So I said it's in Italian. I pasted in all the chats. All right. So this was from a viewer. All right. So basically, as I said before, I have Fedora 43. Which, as I said, it ships with 6.4. So that officially doesn't support AMD Instinct MI60 GPUs. However, what I found out is Fedora has actually taken on themselves to support my GPU in Fedora 43, which it does work. I'll show you how they're working, and also in Fedora 44. Now, the interesting thing is yesterday I checked out, and Fedora 44, at least in what do they call that? Oh my God. Let me grab the link instead of talking here. I believe I have the link. Fedora, I might have to, yeah, here we go. Fedora support, I think this is it here. So if we go here to Fedora, the project, yes, you see it says hardware support for ROCm, ROCm info. So you can see here in Fedora 44, they're going to support my GPU. See here, it's GFX. Oh, did they remove it? Oh, here it is, GFX 906. So I'm lucky they're going to support it. And the good thing about the packages that I said they're in 44 right now, it's 7.1. So I guess they're going to. I looked at the code. All AMD did was just remove the detection part. So I guess you can easily revert that. So as you can see here in Fedora 42, the one I was using before, you see the GPU was supported right here. But I recently upgraded to Fedora 43, and you see Fedora is still supporting it. You see a GFX 906. So they have committed to supporting it in Fedora 44. And you can see here they say limited packages with limited GPU support. Ironically, mine is going to so that's a composable kernel. So the funny thing is mine is going to be fully supported in 44. Yay! Thanks, Fedora. So I'm going to stick with Fedora. I thought I would have to recompile everything. I'm good. So that's the news. The other thing I wanted to show you is before we start in this tutorial, because it's relevant, I'll continue this I guess in a nice stream, is I'm going to go to the AMD website. This information here, it's the I want to show you the specs. So if you look at the specs here, as you can see, it's Vega 20 this TSMC 7 nanometer, the Steam processors, the compute units. The most important part is right here. This four rows right here. So as you can see here, it has peak half precision FP16 at 29.5 teraflops. At FP32, it has 14.7 teraflops. At FP64, I didn't even know there's something as FP64, it's 7.4 teraflops. And this one is interesting. You see it says PIC int 8 performance is 59 teraflops. So what this means is that if you're doing any AI stuff for this particular GPU, it's better to stick with integers. You see that, especially if there are 8 integers here. You see there's 59 sorry, not teraflops. I made a mistake, I apologize. This one here. So the F here stands for, I said it's teraflops, I was wrong. It's actually, it stands for floating point. Sorry, I apologize for that. It stands for floating point. So you can see it's going to be way faster if we use integers instead of floating points. So meaning that the best, if I have to use a floating point, the best one to use is FP16. So this is where stable diffusion.cpp comes in, because you can do conversions there. So meaning that if you get a model that's say FP32, you can get double the performance if you convert it to FP16, and then if you convert it to an integer, you see you'll get 59 another, so like 4 times as fast. So that's what I want to show you guys now. As you can see, because this is an older technology, it doesn't have floating point 8, FP8, right? So most new GPUs today, they do support FP8. So that's why even if they don't have as much VRAM, they do have FP8. So it's gonna be way faster. So for me, in my case, in order to get the optimum speed, I should stick to or convert everything into integers here. So I want to let you guys know. So if you guys are having problems with slowness, now just make sure you have this information about your particular GPU. So just make sure you know which one is for peak performance. Now obviously, if you have like say FP16, FP32, and FP64, they're going to be more accurate, but they're going to be slower. Now if you're doing things like images, a little artifact here and here is perfectly fine, unless you're like super professional. Then obviously instead, in that case, I would get like 3 or 4 of these GPUs. So what I'm saying is, for my use case, I'm perfectly happy with the integer because I care about speed. So there we go. All right, so let's go back to the article here. I'm not overwhelming you. So of course, make sure you obviously installed ROCm, so I did, and make sure you have the development. So this is obviously for Debian-based system, and for Fedora, it's the same thing. Now I'm going to talk about MI Open. That's the equivalence to something like CUDA for AMD. What this does is when you, for example, you're generating an image or especially a video, it will find the best, the most optimal algorithm for it. So it doesn't connect to the internet, it just does it locally. Now what I found is there's a bug. I don't know if it's with ComfyUI, I don't know if it's with Python. So what happens is when it's doing this, it does it in a parallel process. And the problem is because it uses a SQLite database, the SQLite database, if you don't know, it's not meant for parallel connections or multiple parallel connections. So what I found was that if there's more than 2 or 3, actually more than, yeah, just three of them, it actually breaks this, and then you're going to get errors, so which is really annoying. So that could be also the way I think ComfyUI works. Is ComfyUI, when something breaks, even if you type Control-C, there's still some background processes running. So what I decided to do is, I'm pretty happy with the way things work, so I turned this off for ComfyUI. I'll show you. That's why I turned it off. So if you're wondering why I'm showing it and then I turn it off, that's the reason why. So as I said, there's some good news, and I'll explain that in a future tutorial as well. Yeah, so there we go. And then this is what I did in my bashrc file. You can see here I put 9.0.6 devices, H devices. The weird thing is, a lot of this stuff, it actually requires CUDA, so let me rephrase that. It needs to basically it needs to think of your AMD device as a CUDA device. So you need to put this in your bashrc file or in your environment. It says CUDA visible devices. You have to set it to 0, meaning the first one. That's why you see HIP visible devices 0. So the reason you need to do this, if you don't do this, I was scratching my head because I'm like, why is it not working? That's why. It's because it thinks of it needs to think of your device as if it's a CUDA device. You don't have to have CUDA installed. I'm just saying you just need to put this variable in there, because a lot of this stuff was built for, as I've explained before, for Intel CPUs and NVIDIA GPUs. So as you can see here, I put this MI Open debug was it Winograd set to 0, and then I put this to 4. The problem with this is, so this is fine, kind of. I'll explain the problem with this in a second. And this is the one, you see, this is the part where it puts it into the SQLite database. It uses SQLite 3, but the problem, as I said, is you cannot have concurrent connections. It runs in parallel. So if you put it at enforce 4 here, like I did, what that's going to do is, for example, let's say you're testing stuff, you're running a 216 by 216, the width and height. What it's going to do is, the first time it runs, it's going to go and do a whole bunch of algorithms. It might take anywhere from 3 to 10 minutes. Once it's done, everything is fantastic. The problem is, that was a test. So maybe you want a bigger image next time. So the bigger image is going to be 384 by 384, or 384 by 216. The problem is, because those algorithms were for that set, whether the image or video, they're only set for that particular resolution and conditions. So it's going to run this again, which is really annoying. So I changed mine to 3. So what 3 does is, it will see if it exists in the database. If it doesn't exist, it will run the fastest type of algorithms possible. So it won't take more than 3 minutes. So that's why I like the 3. There's others like 0, 1, 0 obviously means off. So as I said, the problem is that I had to turn it off because I said the parallel processes. So I'll have to investigate that. But it does make a difference if you have MI Open, because I've noticed it was, I noticed right away it's like a 30% difference, right? So meaning that, for example, if you're doing a video, the video takes maybe 6 minutes, 30% is going to make a big difference, right? I mean, 30% off is going to be, you drop it down from, 6 minutes down to 4 minutes, or for example, if it's 10 minutes, you get my point. So it is a difference, but I said, I don't like the weighting, especially when I'm testing to see. When I said testing, I mean I want to see if the output is going to be something that's decent before I pick the fastest algorithm. So I'm willing to wait, and then obviously because it will find the fastest algorithm, it will be faster in the future. So this probably is not, it won't make too much of a difference if you have a more recent GPU, but if you have an older one, yeah, the older, the more a bigger the difference this will make. And then of course, if you source this, you don't have to reboot your system, and then you can type ROCm info, and then of course once you clone the ComfyUI, you just type python space ComfyUI.py and then ComfyUI start. Now, as I said, these are the you force. So the problem is ComfyUI or the Python dependencies. They're going to look at your ROCm installed in the system. Like I said, in my case, it's going to be 6.4, and they're going to say, "Oh no, 6.4 is not supported." So this is why these variables are very crucial. You need to put these variables in there. They're very crucial so that it kind of bypasses. It's a little hack, if you will. And if you want to know more about the MI Open, I explain it right here. It's a paragraph, so you can go read up more on it. All right. So as before, for ComfyUI, you just put your, where you put the models, the checkpoints, LoRa's, the VAEs, the control net, and here's my entire system. As you can see, I have an AMD Ryzen 5 5600 GT, 6 cores, 12 threads. 32 gigs of DDR4 RAM. The GPU, one more time, it's AMD Instinct MI60, 32 gigs HBM2. I'm using Fedora 43, I have GNOME 49 desktop. Now, I don't really, the 32 gigs of DDR4, that is not quite accurate because I use the integrated graphics to plug in the displays and do everything else. So that one reserves 4 gigs, so I'm already down to 28 gigs of RAM. And then from that 28 gigs of RAM, somewhere between 4 and 8 is used for ZRAM. That's what we call it, like for swap. So that's something really usable. And plus, one of the things I'm running like right now, I'm using OBS. I have some browsers open. So what I'm saying is the really usable free RAM is probably somewhere around 21 gigs. Might even be less than that. So I'm saying be aware of that when you're downloading models. That's why it's very important. I showed you that. Make sure you convert them into something that will be fast for your system. The smaller, the better as well. Okay, so, and then as you can see, I have all the, of course, you have to make a virtual environment. You don't have to make a virtual environment. I prefer running in a Python virtual environment. The reason for that is if it installs a bunch of dependencies, so it's easy to remove them. It's just have to remove the folder and that's it. You're done. Nice and simple. And you can see here it was running, and it ran actually pretty fast because, as you can see, I was able to generate all these images. I used the v-5 pruned Imoni with the FP16 as one more time, in case you don't know. You see it is supported here. So as you can see, and today's live stream, I did use stable-diffusion.cpp to convert it to also an to an integer, so we can compare the speed. You guys will see how fast it will be. The good thing is on the command line, it actually shows you how quickly it outputs it. So we'll test both of them, and you can see. So I expect it to be twice as fast. I think it was taking 6 seconds or 16 seconds, one of them, I can't remember. So I expect it to be much faster. And that's it. Those are performance things. We'll take care of that. All right, and then these are the screenshots. Okay, those are just the images. I think I already explained that. Yes, I did. As you can see here, is this? Yeah, this was when I was using MI Open. So I expect, you see, they all took 6 no, is it? Yeah, they all took 6 seconds using MI open. Now I said I've removed MI open, so unless it's cached somewhere, so this is probably going to be, so you can see the difference, right? 10 seconds, and then you see 6.4 seconds. So I said it does make a significant difference. However, in my case, I am going to, so in case you're wondering how I was able to do this, it's very simple. I said I had the good thing about the virtual environment is that you can open up another one and run some code there as well. I'll show you all that stuff today, and this is the live stream to prove them live. So you can, okay, just stop that. So I'm just going to scroll this down here. We can check the results soon and all this other stuff. All right. So let's jump here to the command line. As you can see, ComfyUI is right here. You know what? I don't know if there's an update. Let me go and see if there's an update for ComfyUI. Let's go check out here if there's a is there an update for ComfyUI. I'll show you. I think I might have. Let's go check it out. ComfyUI.com. Oh, this is their website. So is there? Okay. Let's go download. Install from GitHub. Let's go to GitHub. So okay. Unfortunately, the last update was 2 days ago. So I believe. I don't know. Let me actually see what time it was. Does it say the time? I'm not sure what version I have. We'll find out on the command line. Okay, so let's get started here. So I'm gonna go to this one here, and I'm gonna open up the cooler control. Remember, this GPU didn't come with it has no cooling, so I got a fan shroud with a 40mm fan. Okay, so I need to start this up. I need to update this app as well. I noticed there's a new version, but it works perfectly fine. So this is just for cooling. I need to go to this IP address, localhost, then the port number is 11987. So I'll open that up. And then for ComfyUI, I just go to cd ComfyUI, and then in here I just type source. Actually, before I do that, let me check the git log. It should tell me what version we have. So this says 18th. What's the date today? So 7. So it says here 7/14/11. So I did it 11 in the morning. I wish there was a way to. Okay, it's in the README file. So I thought it would be here to tell me. Oh, wait, is this full changelog v? I wish it would give the commit. Maybe they put the commit here. Let me go check it out. What's the commit name? Okay, I can't make that out. So I'll show you another way you can find. I believe it. They said it's in the README file. So let's go. Okay, so this one is not needed. You quit. I think they do have a README file here. README. Okay, hopefully it's in the README. So I'm just gonna go less read. Okay. Okay, looks like it's oh, I think let me zoom out a little bit. Oh, okay, that's not what I wanted. I was hoping they would show me the version number. I guess. Oh, version ComfyUI version.py. Okay, so I don't know. Let me try this one. Less ComfyUI version pi. So the version is 0.3.69. Okay, that's fantastic. So that tells me that the one I got was this one, which was 3 days ago. So I haven't run ComfyUI since. That's perfect. So you guys will see a live update. So we're going to update to 0.3.7. So I'm going to show you how to do that. Okay, so let me clear this up. So all you need to do is, because I used git a clone, all I have to do is, because I'm running let me see, is it git version? Yeah, so I'm running git version 2.51.1, so I don't need to do anything fancy. All I need to do is just type git pull inside the folder. That's all I need to do, and you see it grabbed all the changes, as you can see here. Now you see here so basically now I am at 0.3.70, and you can see clearly by doing that it grabbed all of this new new stuff. And so the ComfyUI version has changed as well. You see there's been 2 changes to it. That's clearly the version number. So for example, if I use less again and we check it out, now you see it says 0.3.70. so I have now updated it. However, sometimes some dependencies change. So what you should always do is run the what do you call it, the pip install requirements again. Now I'll show you how to do that. Quit. So what you should do is obviously just type Python, and then what do you call it, Python -m vnve, and then the name of your the name of the what do you call it, the environment. So you see I already have one here, ROCm -vn here, and then what I do is I put it outside the folder because I didn't want to overwrite it. So then I just go one back, I say ROCm/vn/activate. So it's been activated, and I've already done this, but you can I'll type it again. It's already there. It should so you see I pip space install space torch vision space torch audio, and then space hyphen index hyphen URL, and then the HTTPS :/download.pytorch.org/WHL, that stands for wheel, / you see ROCm 6.4. Now that's the one I said that's in Fedora 43, as you guys saw explain that. So then just press enter. Then you can see it's already been installed, so it's not going to install again, but it will install it. Then after that you just type pip space install space -r space requirements.txt. So you enter that, and then it's going to install you install all the requirements that it needs. So usually there's some updates as well. So yeah, this is just a warning. I can ignore that. I mean, this is just a minor 25.1.1 to 25.3. It's a minor one, so I can ignore it. So as you can see, it has installed all this stuff again, successfully uninstalled. For example, you can see it. Is there a minor update? Uninstalling. So basically they're exactly the same. I don't think there's anything different here, but you can do that as well. All right, so then after that, you just type Python. Oh, before I do that, let me open up another. I can do it here as well. So I type ROCm info. Let me zoom out a little bit so you can see what's going on here. So you can see it should have detected my GPU properly, and it's working. As you can see here, ROCm info. You see this is the integrated graphics, obviously because it's a Ryzen 5 5700 GT. The G obviously stands for integrated graphics. That's another one I care about. The one I care about is this one here, GFX 906. So let me zoom in here. This is the one I care about, GFX 906. You see this is the one, it's a GPU, node 1, and it detected it. That's exactly what it wants. So one of the other things that confused me, it says kernel here. They're GPU kernels. That confused me because in Linux we also use kernels for the distribution. So as you can see, you can look through all of this stuff here, blah 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 blah. So that's enough. So ROCm, as you can tell, is working perfectly fine. Now, if you want to know where, if you want to install it, you can also install it yourself using Python. I don't recommend doing, but if you do, as I said, all you have to do is follow the instructions. I'll explain to you what the tensors are. So if we in my system, for example, I'll show you. Some other things you might do is you might get an error about this folder /opt/AMD GPU. So you might get an error there. So all you have to do is sometimes you have to just create a link. You have to create the folder and just create a link to, if it's not detected, just create a link to your /user shares. This is for the AMD. I'll explain what I mean. If it doesn't find the IDs, at least in Fedora, this is where they are. If I type ls, you see this is where they are. They're in /user/share libdrm/AMD GPUs. So sometimes it might say it can't find it, so you have to create this folder in the /opt folder. Is there anything in /opt, by the way? Yeah, I did. See, I did create AMD GPU. This is just a link to this one, and I'll prove it to you if I just type ls-lh, and I just type /AMD GPU. Oops. Share. Okay. Yeah, you see, it's just a link. When you see this L here stands for link. It's just a link to /share. So that's one warnings you'll get. So that's one thing I had to do. I just create the folder, libdrm in the opt folder, and then I just linked it there. Because by default, if you get the package from AMD itself, it will install it in the /opt folder. So it's still looking for that. So if you that warning, to get rid of it, you just that's what you do. And then the other thing is you're gonna need. So sometimes if you install a different version, for example, like I said, Fedora comes with 6.4. Let's say I wanted to install 6.3, or I wanted to install what version is that? Or a higher version, like 6 months people have it, like 7. If I want to install 7, obviously that Fedora doesn't have that one, and Fedora 43, excuse me. So if I did that, then I would have to also, that one is going to be missing the tensor files. So the tensor files, I'm going to show you all of them right now. I'm going to use find because I only care about this. There's several of them, but I only care about specific ones. So I'm going to paste this in here. And you can see these are the tensor files, the tensor libraries. You see all of them here? It will say GFX906, GFX906. So these are the ones you just need to copy. That's it. So I said, for me, lucky like Fedora has decided they're going to keep them, so I'm okay with that. And then, of course, what you might have to do is, I think I actually had to do this. I copied them over to my environmental file. And I'll explain to you if you remember this this one here. So I copied them here, and you can see they're in lib64 here, Python 3.14, and side packages. We go to torch, TTTT was, I should type torch instead, TO, yeah, torch. And then you go to lib, where's LLL for lib here. And then we go to rock plus. In rock plus, you go to the library. And the library here is where you see the old kernels for the GPU. And then this one, because it's 9, remember it's 9, we installed 6.4. So they're going to be missing, so just copy them over. So you see I copied them over. You see, so now it says GFX906. So that's another thing I had to do. And you have to do the same thing for 7.0. I haven't seen anybody who successfully, at least at the time of this recording, for 7.1, but that's what you have to do. So just copy over the missing tensor files, and you'll be good to go. So this is the command I used for that. Let me clear this. So this is the command I did. So I just copied over from the /lib64 into the library. So that's it, and then boom, I can now use everything. Now, for the MI open, I want to show you MI open as well. So MI open, that is in this this one here. I put it in the models folder, and this is MI open. You see, MI open is gonna create all this different algorithm that it stores into into a SQLite database. As I said before, the problem is I had to turn this off because it was running in parallel, and SQLite, if you don't know, it doesn't do concurrent. It's not capable of doing concurrent connections. Concurrent means that you could for example, like if you have a MySQL or MariaDB database, you could use it one database, and you could have like multiple websites. So each of them, or even the same website, people are getting different content, searching, whatever. So it's capable of doing that. That's called a concurrent, meaning that multiple connections at the same time. SQLite is meant to it's one connection at a time. So that's why it's not very good for busy websites or things like that. If it's just grabbing one information one time, yeah, it's actually pretty fast. But what I'm saying is, it doesn't do concurrent connections. It doesn't have like a lock. For example, even MySQL or MariaDB, they do have a lock if there are too many connections, and then to finish this and then to go down. SQLite doesn't have that. All right, it's a flat database. Okay, so what's the other thing I was going to say? Yeah, so that's MI open. Oh, the other thing I'm going to show you is my bashrc file. So I'm going to use nano for that, since we're in the command line here. Why not? Wait, no, I'll just cut it out. Let me create this. I'll just cut. Go here, bashrc. So you see here, my ROCm spoof hack. So you see here, I have the HSA override GFX. I showed you this in the article, and then we have the HIP visible devices, and you have to also CUDA. You export those. You see, I commented out this MI open stuff because I said it was giving me issues. I explained that again, and so I commented that stuff out. And this PyTorch ROCm ARC GFX 906. So that's it. That's all I did, and I was able to get ComfyUI. Now let's actually get started with ComfyUI. I also downloaded some stuff. You see, I also have Stable Diffusion here. Okay, so with that said, let me clear this and just start up Python main.py, and we'll see here. You see, it should detect my GPU. In a second, we'll see what's going on. You'll see if you detect the GPU, it will tell us here what's going on. Remember, it's ROCm 6.4. You see it working. What is going on? Come on. I'm gonna take a sip. Oh, there we go. So you see the VRAM 32 gigs. It detected them, and I said the RAM here, and you can see here the AMD ARC GFX 906. So that's the GPU, and CUDA 0, whatever, AMD Radeon graphics native, and you see it did find it. So we're good. And then obviously this is the default UI, what do you call it? Port 8188 on your local workstation to get say ComfyUI is working, and it's completely detected the GPU. Ta-da! So we can use the GPU. And I said I turned off the MI open as you saw, and I said there's a fix for that. It's going to be off. So we have the cooler. And we have our here. Now I don't actually need the cooler because I'm not going to do video. I'm just going to do. So again, to prove to you that it did work, so we go here, and I've been testing it. So where is the output? You can see I did test it. This is the default image. So this stuff here is the ones that didn't work. That was when I was testing many different things. So you see, I was able to produce stuff, even some videos. So the videos are in here. You can see I was able to produce videos as well, just to prove to you that the GPU works. Perfect. So all this were created by the GPU. So let's look at the videos first. So this one was created by LTX. Come on. What is wrong with you? Yeah, there we go. Oh, I opened up two of them. So as you can see, it came out really nice. This is LTX. This one was LTX text to video. This one is also LTX, this Fox one. Oops, I pressed it twice. Oh, come on. So there we go. This one was an image to video, so it came out well. And then I took a picture of myself, and I tried to. I was kind of lazy. I basically took this this one for the image to video. I put a picture of myself to see what would happen, and it came out weird. But I want to show that to you as well. Okay, so I want to show you. Oops, come on. Yeesh. I don't know why it opens in the center, so let's go back here so you can see. So see that I took a picture of myself, and that's kind of weird, eh? Like my face turns into a sweater and then it goes. That's kind of weird. And then I changed the prompt for this. This one is like this one here. It's a brunette, basically talking and smiling to a woman, a blonde-haired woman. So I changed it to a dark male because it said female. I changed every part where it said woman to man, and the part where I think it says light. I think it said light skin, so I changed to dark skin just to see what it would come up with. And it came out with something not too shabby. There we go. Guy looks brownish because of the hair. Yeah, but there you go. And this one was the last one here. This was an SVD, that stands for Stable Video Diffusion. I don't know if there was a prompt or no, I think there was an image. So let's play this one. I think it was, no, yeah, this was the default image. Let's play it here. So open up again. And you see it's actually this one was just the default one. Yeah, so I think this one was actually the highest res. See what resolution. Yeah, this one was 1024 by 576 2 seconds. These other videos, or all of them, should be the same. I just left the default settings. It was 768 by 512. So although people badmouth LTX video, yeah, 768 by 512. I find it it was fine for ComfyUI. It's one of the fastest. Actually, it's the fastest. So there we go. 4 seconds, as you can see. So they all work, and you can see the outputs for, I believe, this one, for example. This is the default image. Now I could use a different model, but that's perfectly fine. So what I'm going to do here is I'm going to just generate some images. So let's take a look at this ones, which were generated by the V1-5 model. So as you can see there, sorry, this was for Mayor of Toronto. This one was for the GNOME desktop. This one is for an astronaut riding a horse. This one is for Chicken Run. That came out not too shabby. And then a man wearing a watch. I was actually surprised about that. And this is a spider web on web sockets. Web sockets. Okay. So, and this one here, I think I took this one from. This one was done by. What do you call it? I think this was done by stable-diffusion.cpp. I just wanted a Fox, so that I can use the Fox to for the video. So I wanted something generated really fast, so that's what I did here, the Fox. I don't know if it might have been generated by ComfyUI, I'm not sure. No, it wasn't generated by ComfyUI. ComfyUI always adds this ComfyUI 000 something. So yeah, this was generated by stable-diffusion. Just needed something quickly, and this is the one I was used in the video. I just needed a Fox. I think I just put red Fox, and that came out perfectly. All right, so with that said, let me grab a web browser here. I wonder if I can actually use no, better not. All right. Oh, in my live stream, Tronicon Soma says nice stream. Thank you, Tronicon. Be sure to subscribe if you haven't. All right, so I'm gonna open up this here. So before we continue, I'm gonna try silver water. All right. So you can go to localhost to 127, doesn't really matter. So this is going to be for cooler control. If you don't know how this works, is as I said, the GPU, this is the one, this is the dedicated GPU. This is the integrated GPU, so I don't need the integrated GPU. I don't need the Wi-Fi card as well. And the fan number 2, system fan 2. This is the one that I manually use to control the GPU. Now, in case you're wondering why I don't use a fan profile or even a system fan profile, the reason I don't do that is because when you're using AI stuff, the temperature jumps in like a millisecond. Okay, the fan profile is not going to keep up with that. So what I've discovered, the best option for me is before I run any AI stuff, I do it manually. So what I do is I set this to 50%, and I get ready to hit apply as soon as this temperature starts going up. I found that's the best way to control it, because even if you see the CPU, sometimes when you use the CPU temperature jumps, and that one has a fan profile. Use the auto fan profile, and it's still, the temperatures will stay around somewhere between 60 to 80 degrees. So that's why I said I prefer doing it manually here, because with manually, if the temperature goes above 80, way above 80, I'll can panic, and then I can easily go to 100% if I need to. So that's why manual is fine by me. All right, so the other one is 8188, I believe. Yeah, so that one I just use localhost to go to ComfyUI. And you can see this is the LTX video. We're not doing video, as I said. We're going to do images. We're going to do a test between the F, as I said before, the F, what is it, FP16 and FP8. Okay, so what I do is I go here. I think it's this one, templates. Oh, let me open up a new tab here. So I'll go to templates, and under templates, I'm going to, I want images. I just click image. So image here. It's just the default one. I think it's. I think it's actually called default. Now I said I use that one because it's fast. The quality. Yeah, this is the image generation. This is the one I use. So I have everything here. I'll zoom in just to prove to you guys. Let me zoom in here. So you can see it only uses one. You have to put it in the checkpoint. It's the V. Let me zoom up a little bit more. Come on. Oh, too much. Yikes. What? Oh. What is going on here? Oh, it's zooming in here. I want to zoom into the browser. That's not what I want. Okay, there we go. What the? Okay, Control 0. Okay, Control 0. Okay, reset. So I want to just zoom in here. That was weird. Okay. Oh, I didn't realize. Oh, can I drag this? Oh, okay, there we go. I didn't realize. Okay, that's what that's for. I learned something. There we go. I learned something today. I didn't realize you could. Okay, there we go. You could zoom in. Okay, this is perfect. Okay, so there's only one model here. It's in the checkpoints. And as I said, it's the V1-5 pruned Immunity-FP16.safe tensors. Now, this model is the reason I like to use it is it's fast. And I said, if you remember, if we go back to our AMD here, this GPU is capable of running it because it's an FP16. But the thing is, it's going to run, because it's a floating point, it's going to run at those T tops. The FL stands for floating points, so that's Terra floating points, whatever. I can't remember what top stands for. Okay, so I can't be bothered right now. Okay, so we're going to test the speed of this. As I said, this is just the default template. You can see basically just takes that that model from the checkpoints. And then the prompt, it just says beautiful scenery, natural glass bottle, landscape, purple galaxy bottle. And then the negative prompt, it's is this negative prompt? It's just text and watermark. Okay, that's a conditioning. I thought that's a negative prompt. Okay, oh, yeah, it is a negative prompt. I was right. So it's text and watermark. So meaning you should have a watermark. You shouldn't have any text. And then obviously here we have the image size. It's 512 by 512. The batch is only 1. And then here we have our K sampler. So our K sampler, we said this is random. The control after generate is randomized. The steps are 20. The CFG is set to 8. Oh, that's pretty high. I didn't realize it was 8. Okay. The sampler name is Euler, and then the scheduler is normal, and denoise is 1.0, and then the file output will be whatever the default is, and the file output will be actually, I think it'll be put right here with a name, this name here. All right, so I'm gonna run this, and yeah, so I'm gonna hit run here. And then you can check the temperature. So just to be aware, the temperature here, temperature will be perfectly fine. So I'm not worried about that. I'm not even going to bother turning on the fan. You see the temperature is 52, which is fine. And then when the temperature drops, I know it's finished. So it's running. It's running. 60 is fine. 63. Now you see it's back to 60, so it's dropping, meaning that it has finished. So that's why I said I'm okay with that. It's only going to be 60 or 63 for just a few seconds, so that's perfectly fine because the fan is still running at 2% at 20, just below 2900 RPM, which is perfectly fine. All right, so let's go to the command line, and we can see what happened is right here. It said got prompt. You see it's using float 16. And then split via E, blah blah blah, and then it loaded. This one also got me. I was like, what is this? But I guess this is some weird random number there. So you can see it used how much. What is it? I know it used VRAM because we saw the temperature go up. So it loaded. That's actually pretty big. And then the prompt is in 30.42 seconds. So that is pretty high. That is pretty high. You know what? I think that's a little bit unfair. But you guys saw it took 30 seconds. Obviously, I said if I was using mopen, it would be way faster than that. But that is a little bit high. I'm surprised. The GPU is not used for anything else. For example, I took it off before. I used to use it for recording the video, but it's completely open. That is actually pretty high. But it did generate the image. Let's go take a look at that image. So this is the image it generated. Oh, I was wrong. Sorry. I guess it does. Okay. So SD. I didn't realize it did that. I guess I must have changed it or something. Yeah. So here's the image it generated. So not bad. Not bad at all. You know, this reminds me of something I did in what do you call that? Blender Python API, the magic portion one. So there we go. So that took, as you saw, that took how many seconds was that again? So let me actually write that down so I don't forget. So that took, let's see here. So 30.42 seconds. And yeah, so that took 30.42 seconds. Now I'm going to run this again. I'm going to use a different model, and I'll show you what model I'm going to use. So for that one, I'm going to go here. And remember, it's in checkpoint, so we'll go to ComfyUI. We go to models, checkpoints, and this is the one it used. You see this one, V-5F16. So you see, I did create a Q8 one. So Q8, obviously that means it's an integer, and then I also created a Q4 one. So we're going to test to see how much faster it will be when we use this model and then we use this model. Now, it doesn't actually output everything here. However, it should be okay. So that's another, it doesn't have a verbose mode. I don't know if there's a way to turn on. If you guys know how to turn on verbose in ComfyUI, let me know. So we're going to test this one now. I generated this ones. You most likely won't be able to download this one. So you just do a conversion using stable-diffusion.cpp. They do have a binary as well. So this ones don't need a GPU. You can simply just run it on your CPU. It's perfectly fine. It'll take literally just a few seconds to generate because it's just a conversion. And the file is not that big. For example, this file is 2.1 gigs. So you can see when it converted into an integer, Q8, becomes 1.8, and then when it comes a Q4 it becomes 1.7. So there's not really too much difference between these ones. Now I expect this one to be much faster than even this one. This one is not bad. There's going to be some artifacts, but if you're limited with memory or your GPU VRAM, using a model like this is perfectly fine. You could just add more steps, so it's a little bit slower, but because it's much smaller, you will be able to you'll be able to make up that difference. Okay, so let's go back and we're going to change the model. Let's go back here to default. I don't need this one, so this is the default. I'm going to just change it. Oh, it doesn't matter. I'm not going to change it. Let's go back here. Oh, this is a nice little feature. I was wondering what this was for. Now I know. Oh, it also has a zoom here. Okay, it has a zoom control here too. Okay, that's fine. So that's another one I want. This is the one I want. So I'm going to change this. I'm hoping it's not hard coded to this one. So I'm going to see if I can change it. Yes, I can. Okay, so oh, looks like I might have to. Looks like it's not going to work. It didn't detect it in the filter. Can I just type V? Where's V? No, it's not detecting. I guess this must be hard coded. So I might have to pick my own. Yeah, unfortunately, looks like I don't. Looks like it's hard coded for this one. Let me see if there's a way to load model libraries, checkpoints. Wow, this is actually pretty. Can I resize it? Okay, perfect. So it's in the checkpoints, but it's not detecting it. Yeah, it's not detecting it. That's a shame. It's not detecting it. It's only detecting VP16. So I guess this particular one is. Oh, can I have? I wonder if I can replace this with my own. Let me try something here. Let me see if I can replace. Can I get rid of this? Oh, perfect. I want to see if I can replace the load model with my own load model. So this is something that one of my viewers taught me. I think you can right click anywhere here. Yeah, so you can right click. He told me this. He said, I didn't know this. Right click and click add mode. So I want a loader. Is it image or loader? Okay, so just a second here. I think I need to go like this. Let me go here. Right click here. Add node. Loader. So video. Load image from dataset. What type of node is that one? Oh, I think there's a way if I click it's just load model. Okay, maybe I have to go to. Is it image? Does the image have a loader? Load image. Here we go. Load image. Oh no, that's not the one I wanted. Okay, so it must be load model then. Loaders. Is it load checkpoint? Must be load checkpoint. It is a checkpoint. So let me try this one. Load checkpoint. Yes, it is a load checkpoint. Yes, it is a load checkpoint. Okay, perfect. I see a whole bunch of stuff. Okay, so what I'm going to do is. It's still not picking up my. It's not picking them up. That's a shame. Okay, so it looks like this particular guy is only hard coded for the. I thought I would be able to use my own. Yeah, so it looks like it's not finding it. I guess maybe the naming convention is weird or something. It's not finding my V. I would like to use my V, the different one, but looks like I cannot. So I might as well just delete this guy. So I don't know that because I'm still not too familiar with. Okay, I'll just delete. So I'm not able to change the model. I was hoping I'll be able. I guess unless maybe I use a custom model. Yeah. So it looks like I cannot pick it. Yeah. So I guess this one is hard coded to. I probably have to change the JSON file Oh, you know what? I wonder if I can do that. Let's try that. So let me rename this. Where is this one here? I'll go to File. Let's go Save As, and I'll call this Q8 image. Go here and File, Export. Yeah, confirm. Okay, where did it go? I guess it went in my downloads folder. Let's go check. Did it go down? Yeah, it went to downloads folder. Okay, so here I'm gonna open this up with where's the GNOME editor? Where's the GNOME editor here? You kidding me? I'll use Guinea. Wow. Wow, okay. That's weird. Okay, I'll just open up manually. Oops. And we can drag it. Drag it into here. Let's see if we can figure this out. Man, the glare, I can't see properly. It's a dark theme problem. Alright, so let's see, case sampler, that's not what I care about. Latent image, image slot. Latent image. Different models are trained on different data sets. Okay, I don't care about that. Okay, I'm gonna see if I can, what is it, Control F? Was it V1, I think it was? Yeah, here we go, name. Ah, I was right. So it is hard-coded. It is hard-coded to, yeah, so it's hard-coded to grab the particular image. So I'm gonna, oh no, that's for downloading. That's a download one, so I don't care about that one. That's for downloading. Yeah, that's to download it. So I do not care about. Should I put it here? Maybe confused. Let's continue down. It says there's 8 of them. Tutorial, but this looks like it's just value tutorial. That's not it. Okay, I don't know. I have to go look that up. I don't know, because that's just a link to download it. Wait, what's the difference here? Is this the one? Properties clip. Checkpoint loader. Oh, the loader. Okay, so the loader. No, because there's also that's the tutorial, and it's just the link. So this is widget values. Models. I'm not sure if this is the one I changed, because because there's 2 places. See, you have it here. You have this here. Yeah, this is the model link. So this is the one. That's not the, yeah. So that's the one I'm looking for. Is this one here? But it's not letting me pick a different model. So maybe I need to have a custom nodes or something like that. But anyway, so it does work. And I said I did test it using stable-diffusion. Anyway, I think that's enough for this tutorial. I will, as I said, the purpose of this tutorial is to show you how to reinstall ComfyUI if you have any, if you got rid of it for some reason. So, in case you're wondering why I installed it, it's because I wanted proof that you can actually use a different version of ROCm. Yes, there's a lot of tutorials out there. But as I said before, when I tried to run it inside with GPU pass-through, it failed. I tried to run it in a Podman container, that failed. I used DistroBox. That one actually did work, except the problem was I also had problems running some other applications where now I know what the problem was, and I'll explain that in a future tutorial. So DistroBox does work. I prefer DistroBox to running, say, the problem with GPU pass-through is that I have to allocate a bunch of resources to the virtual machine. So I didn't like that option. So yeah, the DistroBox, you're basically running another operating system, and I was hoping to run Fedora, but that didn't work. So you needed to run the AMD one. That's massive. For example, if you notice the tutorial I did, if you get the full Ubuntu, it's 5 gigs, but after it expands, you need like 60 gigs, which is crazy. And then the terminal one, that's much better, but you have to do a lot of manual stuff, which I didn't want to do. So this method I'm showing you here from the Fedora repos works perfectly fine. And I said I'll figure out how to change the I'll figure out how to change the what do you call it, the loader, so it picks up the I can choose a different what do you call it, I can pick a different model, because I did the quantized ones are obviously way better. So I said it might be just be a custom node that I just need to use. I don't think there's, yeah, so I probably just need a custom node or something like that where I can do that myself. Okay, so yeah, so let's do this thing here. Oh, loaders, what is this one? Deprecated, modal load patcher, load diffusion model, load clip. So I don't know, maybe I'll try config as deprecated. I might try one of those later off screen. All right, so let's finish this tutorial up. As you guys saw, I already showed you the results, the Mayor of Toronto, GNOME desktop, astronaut riding a horse, chicken run, man a watch, spiderweb on Sprocket. So not too bad for this particular model. The reason I like this model is because I said it's small, and there's ways you can speed it up. I'll give you an example. Other ways you can speed it up is, for example, if you go here, you can drop the number, you can fool around with the sampler and the scheduler and the CFG value, and obviously the number of steps as well. If you're looking to expand your programming skill, I also offer great resources. I have a book called Learning Python. It's a beginner-friendly guide to learning Python. It's available on Amazon. The links are also in the description. I have a course. It's called Learning Python. It's available on jamboshop.com. It's a detailed course that covers Python basics and intermediate topics. Last year I did spend a lot of time using the web IDE for the jamboshop.com Learning Python course. So if you need coupons for it, let me know. The links are also in the description to go to jamboshop.com. And if you need one-on-one Python tutorials, if you need personalized help with Python programming, feel free to reach out for one-on-one online tutorials at jambo.com/contact. The links are also in the description. And if you need assistance with ROCm or want to migrate your desk setup, you can contact me at jamboservices.com/contact. There's also other ways you can contact me. The links are in the description, but you can send a comment. There's a comment for this article as well. Any of the channels, I'll show you the channels as well. We'll scroll down later. And obviously on the websites, the web forms. Yeah, there are a lot of ways you can contact me or get my attention. All right. So with that said, again, I implore you to subscribe, like, follow, and leave comments. It helps the channel grow. As I said before, I'd like to thank everybody who subscribed so far this month. We are close to hitting a milestone on YouTube, BitChute, Rumble, and Odyssey. Thank you very much, everybody. Okay, so I do have some other resources here as well. If you're interested, I live in a rural area in a cabin. So there's no internet, the cellular service is sporadic. So I use the SpaceX Starlink residential service. So if you're thinking of getting it, please use my referral link. You go to jambo.com, pick any article, and just scroll down. You'll see the recommended resources. It's right there. It's the one at the bottom at the time of this recording. So with that, I'll get 1 month free, and you will get a discount. In Canada right now, you're getting the equipment for free. So remember I said the cellular service is sporadic. Now thanks to this SpaceX Starlink residential service, I'm able to use Wi-Fi calling that lets me call and receive voice calls, text messages, including the multimedia text messages as well, without having to pay any roaming charges. So here, this is the referral link you can use. If you're in Canada, I said you get the equipment for free. If you're anywhere else in the world, the type of discount and this duration is based on your geographical location, but you will get a significant discount. The other one is this. This is an affiliate link. It's the Honeywell HeatPad Personal Ceramic Heater. It's available on Amazon. It has off, low, and high settings, and has a trip protection, meaning if it flips over anything, it will stop. It will automatically turn off. So the low uses 170 watts, high uses 250 watts. This little guy helped me save over $100 on the coldest month of last winter in February. I paid $250 for propane. Propane is only used for heating this place. So that's a significant savings. The previous year where it was a mild winter, I was paying $350 every single month. So you can imagine. And this winter I'm going to save even more money because I'm starting early. For example, even right now, I only turned on the heater on November 1st. And I set the temperature to 15 degrees. So that means that in my personal space here, I can use this little guy to, if I need a little boost in heat. And obviously I'm going to dress more warmly. That's a mistake I also made in my first year. So that will help me a lot. So if you pick this up, I'll get a commission. Please use my affiliate link. It's right here as well. See, buy the Honeywell HeatPad Personal Ceramic Heater. If you guys have any other things you'd like me to review, like hardware, or some other affiliate links, let me know. I'll be glad to do that. And finally, my own, I created a novelette. It's called The Algorithmic Serpent, and it's by me. See my name there, ROCm. It's about a scientist who creates an AI system and loses his mind. So he has to regain control of his mind and the AI system. This is the back. It's a psychological thriller. I can open up so you can see the pages in there. You see the old pages. There's also an ebook version. The ebook version is free if you have Kindle Unlimited, so be sure to pick it up if you have the means. I made them as affordable as possible. They're almost at cost. This one is for printing and shipping costs, and the ebook version is for storage costs. So let me know what you think. I love writing, and I want to improve my writing as well, not just for programming skills. I like to write other things like non-fiction or fantasy type stuff. Alright, so here's a bio about me. Edward, you can see I'm a freelance programmer. My book page on Amazon, it's right here, the link. If you need support, jamboservices.com, the link is right here. And if you want courses, jamboshop.com, the link is also right there. And if you scroll all the way down to the footer, I also have the channels, Odyssey, Rumble, BitChute, and YouTube. Okay, with that said, this tutorial is over. I'm going to take a look at all the live chats. I'm going to start with BitChute. There's no live chat there. Go to, what's this one? Rumble, no live chat today. And Odyssey, there's no live chat. And YouTube, I only had one from Tronicon Soma, who said nice stream. Thanks again, everybody, for joining. Be sure to join the night stream tonight. I will continue on this because there have been some updates with not ComfyUI, obviously ComfyUI, but there's also been some updates with stable-diffusion.cpp. I'm actually able to get video working, but not just any video. I'm able to get 2.1. Remember, I was never able to get any video working on 2.1. Guess what? I'm able to get 2.1, and using the default stuff, I'm able to get video working. And I'll show you the trick I did to prevent, don't compile with Vulkan. It interferes with ROCm. I'll show you how to get it. It's working pretty well. And I will be able to the comparison between FP16, Q8, and Q4. You guys will see that in tonight's live stream. Okay, see you then.